All right, guys, let's look at this question here. Which of the following statements is not true concerning the equation x squared minus c equals 0 for c greater than 0? Okay, so what I'm going to do here is let's go through A, B, C, D. Let's just try to prove each one and see what's going on here. So the first thing I would say is it's saying choose the incorrect statement. Okay, so 3 of these should be correct and then 1 should be incorrect. Let's see here. A quadratic equation in this form can always be solved using the square root property. So if I give you x squared minus c equals 0, if I add c to both sides, x squared equals c, and I can take the square root of both sides. The real question that should be popping in your head is, when can you not do this? So they say something off to the side. They say that c has to be, I think they actually say c is greater than 0. Yeah. So if c is greater than 0, that means this inside value right here has to be positive. Okay? It has to be positive. There's no way it can be anything other than positive. So if that's the case, you can always take the square root of positive, and that's true. If this was not given, this statement would actually be false. So be aware of that, because on a test or a quiz or something, you may say something slightly different. Okay, let's see. B. This equation is not considered to be a quadratic equation because it is not of the form ax squared plus bx plus c equals 0. Okay, this actually is of the form ax squared. Let me draw a line here. Ax squared plus bx plus c. Okay, it may not be 100% obvious, but a is 1. Okay, this value here would be 1. B, though not written, b is actually 0x. Okay, so there's actually a plus 0x in here. And then this says negative c. Well, this is just c. This is the same thing. You can almost think of this as equivalent to plus c. Okay, so this, in other words, this equation, if I wanted to make it match this form, it's going to be 1x squared plus 0x plus, we can almost say plus negative c. Okay, so it actually does fit that form. So hence the answer here has to be B. Okay. When I was looking at this, C and D seemed a little strange, but I guess we could always, the left-hand side of this equation is called the difference of two squares. I guess we could always argue that because this C value is, again, positive, so you can always take the square root of it. Okay, this is actually, what's that's referencing, just to be clear. Difference of squares is x squared minus y squared is equal to x plus y, and this should be memorized. You should know this every time you see this, x minus y. So if I give you, for example, x squared minus 36, that's automatically x plus 6, x minus 6. If I give you x squared minus 25, that's going to be x plus 5, x minus 5. Again, all I'm doing here, in case this isn't obvious, the square root of x squared is x, the square root of 36 is 6. So you just put the square roots of them plus or minus. Okay, even if I gave you something like x squared minus, let's say 15, that's not pretty, that's okay. It still breaks down to x plus square root 15 and x minus square root 15. So it still works no matter what. It may not be necessarily a nice clean number like 5 or 6, but square root 15 is still a number. So I guess that's what they mean by C. And D is a quadratic equation in this form can always be solved by factoring. So I guess difference, we could always use this property to factor it into two different factors. So we could always do that. So C and D are, I guess we could argue, are kind of related to each other. There may be some better reasons for this, and if I do come across them, I'll make another video in regards to these. But for sure, B is incorrect. Okay, you can rewrite this. This x squared minus c is a quadratic equation, and it is of the form ax squared plus bx plus c equals 0. All right. This great question. If you come across this and you can post some better explanations of C and D, I'd love to hear them. All right, see you in the next video.